as I kind of had our two students demonstrate, okay, we are no longer going to move. I mean, we still will, but instead of moving horizontally and vertically to plot a point, we're going to talk about rotating and moving out on that rotation, okay? And when we do that, it's called polar coordinates. So instead of like a horizontal vertical grid system, we're going to talk about more of a circular grid system, as you see up here, okay? Now, polar coordinates has nothing to do with a polar bear. I'll tell you why they're called polar coordinates here in a moment, okay? So the first thing that I had Max and Dallas demonstrate is what we call rectangular coordinates, okay, where I give you a point x, y, and you move horizontally and then vertically. Okay, or horizontal, vertical, however you wish to do it. That's kind of what happened this morning with Max, because he didn't listen very well. But we eventually got there, right? But we have horizontal and vertical distances. This is what you've been doing, since like pre-algebra? Okay. Well, now we're going to keep the XY axis. We're going to call it something different. We're going to just erase the grid system, and we're going to draw a different grid system on there, okay? So polar coordinates will be r comma theta, where r is that directed distance from the origin. So when Max jumped out, okay, that distance that he jumped at an angle theta, okay? We call these polar coordinates because instead of the origin, we call it the pole. Okay. So r comma theta, where r is that distance we jump out from the pole at a particular angle theta. And I hope you think of Max jumping out to that point every time you plot a pole. Good mental picture. Okay. As you have noticed, x, y are in alphabetical order. R, comma, theta, those are also in alphabetical order. Okay. Typically, I'm going to ask you to think of theta first and then move r. Okay. We kind of, like Max kind of had to turn his body and then jump out. Okay. That's how I'm going to ask you to plot points. But when we write them, we need to write them as r, comma, theta. Okay. So what I'm going to do, let's practice plotting some points, okay? So we are going to plot the point 3, comma, negative 3 pi over 4. Oh, man. I used to have a stamp. I don't know if I have that stamp anymore. Do your best to draw that grid, okay? Okay, so you have some concentric circles. Draw the grid, okay? So draw x-axis, y-axis, diagonal, diagonal, and then draw at least 3 concentric circles. Okay. So this is our new grid system. Okay, and what's going to happen, I'll let you get it all drawn out. Okay, where's our angle of 3, negative 3 pi over 4? Oh, sorry. Where's our angle of negative 3 pi over 4? Do you agree that this right here would be negative 3 pi over 4? So once we turn ourselves to negative 3 pi over 4, then we could walk out 3 grid marks. Okay? What's another way we could describe that coordinate? Okay, we could call this 3 5 pi over 4. We could rotate to 5 pi over 4 and then walk out 3. Okay? There are 2 other ways that we could describe this using angles between negative 2 pi and positive 2 pi. Okay? What's this angle right here? That's pi over 4, right? Well, what if we rotated to pi over 4? How could we get to that coordinate? We would have to move backwards 3. So we could rotate to pi over 4 and move backwards 3 to get to that coordinate. Okay? So if you have a negative r value, that just means you're moving backwards from wherever you're facing. Okay? One more way to describe that coordinate. What'd you say? We could rotate to negative 7 pi over 4 and then move backwards 3. Okay. One of the questions on your quiz tomorrow will be to plot a point and give it a different name. Okay? Do you have a question about how we got to anything up here? Okay? We rotated to an angle and then we walked forward for a positive r, or we rotated to an angle and we walked negative, or we walked backwards for a negative r. Okay, so let's think of the trigonometry behind this. I'm going to just throw a coordinate up here. If I were to plot that point in rectangular form, how would we get there? Use words, Max.
You would go right.
Okay, and specifically how many to the right? Describe it with a letter.
X.
There we go. And we would go up y, is what he said. Okay? Or we could rotate theta and then walk out r. What do you notice? What do we have? All right, so let's write up some trigonometry that we know about this triangle. We know that x squared plus y squared equals r squared, right? So if you have an xy coordinate, we can use the Pythagorean theorem to figure out the r value. How about if we have x and y? How do we get theta? We have x and y. We know that the tangent of theta would be y over x. Man, I feel like we did stuff like this before, right? You remember we did all of our stuff with like vectors and complex numbers? Okay? Okay, on the flip side, what if we have r and theta? How do we get x and y? I'm going to give you 1 minute at your tables to come up with how we would get x and y if we knew r and theta. Go. Don't make it too complicated. This is a right triangle. All right, Kinley, how do we find x? Okay, we can use the different sines and cosines. So we know that the cosine of our angle would be x over r, right? So if we solve for x, x would be r cosine theta. We could do the same thing for y. We know that the sine of theta is y over r. So y would equal r sine of theta. These four equations should be written down and highlighted and boxed and starred. These are what you need for polar coordinates. Okay? For the rest of our time together, I am going to ask us to convert coordinates. I'm going to ask us to convert equations. We will always come back to one of these four when we are doing it. Okay. If we have r and theta, we can plug them into here to get x and y. If we have x and y, we can plug them into here to get r and theta. Okay. Are there any questions about that picture and how we got either of any of those equations? They look familiar, don't they? From chapter 6, if you can remember back that far. Okay, I know. I do want to be clear. We're entering into topics where we will not be using a calculator on. So I know we got to use our calculator for projectile motion and parametric equations, but anything related to polar coordinates, we will not need a calculator for. Okay? So let's go through some examples. The coordinate -1, 1. It's a rectangular coordinate, and I want you to convert it to polar form. Okay? It's not absolutely necessary. However, I do feel that it would help you to plot the point, or at least think about the picture. Okay? So we know x and y. We know x and y. How can we find r? Okay? We know that x squared plus y squared equals r squared. So I can plug -1, 1 into there. R is what? Square root of 2. Technically, it's plus or minus square root of 2, but I'll ask that when you're converting that you just stick with the positive, so then that way when we identify our angle, it's more straightforward. Okay? All right, well, now we need our angle. Okay? Well, we wrote down that the tangent of theta is y over x. Okay, here's where you need to be careful. This is like the one time it's not straightforward when you're converting. We have a number of times where the tangent is equal to -1. So I really need you to think about the picture. We have a coordinate in the second quadrant. So where in the second quadrant is your tangent equal to -1? Say aloud. 3 pi over 4. Okay? Yes, I know that at 7 pi over 4, the tangent's -1, but our coordinate is in the second quadrant, and it needs to match that. Okay? So our conversion would be radical 2, 3 pi over 4. Shall we go the other way? Sure thing?
Sure, why not?
I like the enthusiasm. Okay, radical 3, comma, pi over 6. Let's see. Sydney, which quadrant would this be in? The first quadrant. We have a first quadrant angle with a positive r, okay? So we're going to end up in the first quadrant, which means our xy coordinate should reflect that, okay? Now, when we have a polar coordinate, it's probably easier to convert it to rectangular than the other way around because we have two equations that we have to use, okay? We have x equals r cosine theta, and we have y equals r sine theta, okay? So, r is radical 3, and theta is pi over 6. Okay, well, what is the cosine of pi over 6? Radical 3 over 2. So we have radical 3 over 2 times radical 3. And then what's the sine of pi over 6? 1/2. Radical 3 times 1/2 is radical 3/2. So our coordinate in rectangular form is 3/2 radical 3 over 2. Okay. It may be helpful tomorrow when you get your quiz, or Friday next week when you get your test, to write those 4 conversion formulas at the top of your page so you can see them and reference them as you go throughout your work. Okay? Where it really gets exciting is when I give you equations to convert. Okay? So we are going to go through some equations. R equals 2. This is a polar equation that I want to make into rectangular form. So first of all, I don't want r, I want x and or y. Do we have a conversion formula that involves x and y and r?
Yeah.
Okay, now Ralston, what is it? X squared plus y squared equals r squared. Well, here I just have r. Thank you. I only have r. That is a problem. How do we fix it?
Good question.
We have an r, we need an r squared.
Square it.
Are we allowed to square both sides of an equation?
Yes.
Yeah. So r squared equals 4, and now instead of r squared, we can write x squared plus y squared equals 4. We have a circle centered at the origin with radius 2. Okay, so think about it. R equals 2. R equals 2. Our distance from the origin is always 2. We have a circle of radius 2. Nifty, right? Here, let's go and draw the picture too. Not the best circle I've ever drawn, but that's fine. Okay, our next one, theta equals pi over 3. It is a polar equation that I want to convert into rectangular form. Instead of theta, I want x's and y's. We have the whole tangent thing, huh? Okay, what do we know about tangent of theta equals y over x? Is that right?
Yep.
Okay, well here I have theta is pi over 3. So we can write the tangent of pi over 3 is y over x. Well, what's the tangent of pi over 3? Radical 3. So what we have is a line with slope radical 3. Okay? Oh, great question. Here we have our set of axes. Theta is always pi over 3. So our angle is always pi over 3. This is what that would look like. Okay? A line that goes through the origin is always going to be like theta equals whatever. Theta equals pi over 3, theta equals pi over 4. Okay? Now, which one would be easier to graph? Y equals radical 3x or theta equals pi over 3? Okay, I am not about to do slope. That's irrational. Okay, that would not be very accurate. However, we can measure an angle and draw the line, and it's much more efficient. Okay. All right, one more bonus example here. I'm going to give you 60 seconds to brainstorm how the heck we are going to convert this one.
That's about it. That's about all I got. I'm gonna get your buddy. Like, okay, cool.
Yeah, like, thanks. I'm just being me, guys.
Or I'll just be like, if it's someone that I like, I'll be like, yeah, I know it's funny, okay? Like Riley. But she doesn't tell me that often. Yeah, you said it once.
You guys had a good idea.
Oh, the 1 over sign? Yeah, we didn't know what to do after that.
That's about it.
Yeah. I said, maybe I'll look at that.
Okay, do you see cosecant anywhere in your conversion formulas?
No.
No. Okay. So Mary Kate, what did your table decide to do?
1 over sine instead.
Okay, so we know that cosecant is the same thing as 1 over sine of theta. And then they're like, I'm not sure where to go from there. Any ideas?
Can you like multiply?
Like takes this and multiply it over?
Yeah.
So like r times the sine of theta equals 4?
Yeah. Manga, is that
Yeah, that's okay. Was that helpful?
I couldn't tell from the reaction.
yes, or something?
Why was that helpful?
Makes it prettier. Because now we have our sine theta
And what is r sine theta?
equal to y.
Whoa.
Y equals 4. Okay, now we are going to go the other way. And what I want to make sure you do when we go the other way is that after you use your substitution conversion formulas, I do want you to solve for r if we are talking about a polar equation. when we have a polar equation, I really need you to solve for r. If you can't, because there's not an r, like in that second example we did, then I need you to solve for theta. Okay? So first priority is to solve for r. If r disappears, then solve for theta. As you're writing this down, I do want to remind you that A, there's pep rally schedule tomorrow. But B, in our pep rally schedule, we will have our quiz, and this stuff's going to be on it. So if you're one of those people who doesn't do your homework tonight, that quiz will be a little rough for you tomorrow, okay? So I would encourage you, as I always do, to do your homework tonight. Check your answers. Come with questions. Okay, are we ready? Here's our first example. Start off slow. Give me a thumbs up right here if you think you know the answer to this problem. Okay, Kaya, what do you think it is? And how'd you get there?
R squared would be 16.
Okay, we know that x squared plus y squared is the same as r squared. So we have r equals 4. A circle with radius 4. Bonus example on this page, x equals 3. This is actually the nicer conversion because we always have something to plug in for x and we always have something to plug in for y. What can we plug in for x? R cosine theta. Okay? We know we can plug that in for x. When we were working on our polar stuff, we had to be a little bit creative before we can plug in. When we have rectangular, we can just boom, plug in right away. Well, what did I tell you? We needed to solve for r. So I need to divide that cosine over. And so I would appreciate you writing this as 3 secant theta. If you leave it as 3 divided by cosine theta, I mean, I'm not going to throw a fit, but it does look nicer when you change it to secant. You guys are on right today. 2 more examples. Can you handle it?
Yes.
Okay,
We got this.
we've got this. Okay, write this one down, and then write down what you think the first step would be. So y equals x, and then write down what you think the first step would be. Phone a friend if you need to, not literally, but like ask your neighbor. Okay.
Maybe we could like plug one into the other.
Or you could do r cosine theta and r tan theta.
Sorry.
Okay, there's 2 ways you could go about doing this problem. And as I walked around, I saw 2 different ways. Guy, what was your first step?
I was gonna convert him into the r cosine.
So this is what Guy did. Okay. Then what?
Divide the r out.
Okay, the r's divide out.
And then there's only like 2 places that can happen. It's like first and third.
Okay, so you solved for pi, theta is pi over 4 from there. Okay? Way number 2. Jessica, tell me what you did. Okay, so you had 1 equals y divided by x. Okay, and you know that y divided by x is tangent theta, and that happens at pi over 4. Okay, and technically the line theta equals 5 pi over 4 is the same line as the line theta equals pi over 4. So you would only need one. You wouldn't need both because it's the same line. Okay, but we did have 2 different ways you could go about doing it. Okay, this is probably what most people are going to see right away. I know x is r sine. I know y is r sine theta. I know x is r cosine theta. Okay, but if you see something that's going to make your life a little bit easier, go for it. Okay, last example, then we'll call it a day.
Ooh.
It is a little bit more intense. Whoops, I lost it. Okay, so the past few examples that we've seen, our polar equations have been really nice and simple. Okay, sometimes polar equations are more simple than rectangular. Sometimes rectangular equations are more simple than the polar form. Okay, there's advantages and disadvantages to both depending on what type of graph we're talking about. Okay, here we know that x is r cosine theta, and we know that y is r sine theta. And when we are going to polar form, we want to solve for r. Well, okay. So what I'm going to do is I'm going to go ahead and I'm going to move that 2 to the other side of the equal sign because it doesn't have an r. And now what's true about both terms on the left? They both have an r. And if we have 2 terms that have something in common, we can factor. So we factored out that r. That's what we're solving for. So now in order to get r all by itself, we divide that big chunk over. Okay, here's an example where the polar form is really not pretty. Our rectangular equation is much nicer to work with. Okay, however, if we're talking about a circle at the origin, r equals 4 is a lot easier than x squared plus y squared equals 16. Okay, so you have a homework assignment that you have to look at. Please make sure you're checking your answers and consulting whoever you need to consult if you have questions, whether that be a friend, myself, or Couch Chat. Okay. Thank you for your participation today. Yes.
On the example beforehand, which one would you rather?
I'm okay either way.
Okay.
Mm-hmm.
Or my social skills class.